we want to look at AC circuits. AC circuits. All right, this is what we want to look at. Our topic. Now you may ask, what does A stand for and what does C stand for? A stand for alternating, while C stands for current. So this is called alternating current circuit. Alternating current circuit. You see? Now you may be asked, what is alternating current circuit? Now, alternating current circuit is a circuit through which the alternating current flows. Okay, here is it. Now, alternating current circuit is a circuit through which alternating current flows. See, the path through which the alternating current flows is what we call the alternating current circuit. You've seen it here. Now, here we have known the path. The path through which the alternating current flows is called the alternating current circuit. But what is the alternating current itself? What is the alternating current itself? The alternating current. Now, alternating current. Now, this is a kind, this is a current that flows, or this is a current which changes continually in direction. Let's look at what we have here. An alternating current is a current which changes continually in direction while flowing through a conductor. Now, while a current, let's assume this to be a conductor. Let's assume this to be a conductor. I have my magnitude here. Okay, I have my time here. Now, let's say the current is flowing from here. Okay. Now, as the current is flowing, it's changing in direction. As it is flowing from one point to another, it's changing in direction. As it's flowing, it's changing in direction. Now, the current that changes in direction while flowing through a conductor is what we call the alternating current. I'm sure you understand. So, while flowing, it's changing in direction. That's what makes it alternating current. Now, it is given by this I, capital letter I, equal to I naught sine WT. Now, this WT is your angular speed, but let's not go there. W speed, sorry, the W is equal to 2 pi f. 2 pi f, okay? Now, let's substitute for W in this equation. Now, in the whole of my W, I'm going to remove W and put 2 pi t. Sorry, 2 pi f. So I have this. You understand? In place of W, I replace it with 2 pi f. Then my t is still there. Where I, the capital letter I, stands for instantaneous current in ampere. Do you see it? The instantaneous current in ampere. Now, my I naught from here stands for maximum, or you can call it peak current. We know current is measured in ampere. Then T stands for time. Time is measured in second. Then F is your frequency, and frequency is measured in hertz. Okay, hertz. I'm sure you understand everything from here to here. It's simple. Now, also alternating current, or you can also call it alternating voltage. You can call it alternating current, or you can call it alternating voltage. We have alternating current, we also have alternating voltage. Has a sine wave. Has a sine waveform. Sine waveform. This alternating current is given by. Now, calm down. The same way the alternating current was equal to this particular equation, the alternating voltage can also be equal to something of that same nature. The only difference is that where we have the instantaneous voltage, you are going to also have, where you're supposed to have the instantaneous current, you are going to have the instantaneous voltage. Where you are supposed to have the peak current, you are going to have your peak voltage. These are the same thing. I'm sure you understand. The same thing. Where your phi stands for the instantaneous voltage. Voltage is measured in volts, and you also have your peak voltage. You can equally call it maximum voltage, and it is measured in volts as long as volt is concerned. Okay. Okay. Okay, now you have your WT. This WT is a phase angle. W alone is angular velocity or angular speed. But when you join W and T, it becomes phase angle of the alternating currents. Phase angle of the alternating currents. And it is measured in radians or in degree. I'm sure you understand it up to this point.